All right, let's jump back into it, ladies and gentlemen. Today we're talking about algebra in geometry. Algebra in geometry means we're going to take our algebra concepts and use them to solve a geometry problem. Let's go over here and look at some notes. Today specifically we're talking about volume, and this is for our higher level geometry students, and maybe you're taking algebra and you're in that part of the class where you're talking about finding volumes of different geometric shapes. Nonetheless, volume, which can be represented by the letter V, is simply measured in square blocks. We call those blocks cubes. And so I have a picture of a cube here. And anytime you're finding volume, really you're finding how many of these boxes that look like this go into other shapes. So the question is always, when you're doing volume, how many of these shapes called cubes fit into either one of these, or one of these, or one of these, or one of these, or it could be a pyramid, it could be a cone, it could be any kind of geometric shape. But the question is always, how many cubes can fit within that shape? The question is always, what are you measuring? It could be water, which will be measured in liters, for example. It could be sand. It could be a box of worms. It could be anything that fits into your box, and you want to figure out how many of them will fit into another box, and how many of them will fit into another box, which could be a cylinder, or how many could fit into this tent, for example. But the answers are always measured in cubes. Now here's the shortcut. Love shortcuts. Volume in these geometric shapes, these are called simplified geometric shapes. And these geometric shapes, because they're basics, these are the basics. The area of the base times the height is going to give you your answer. So what am I talking about? I colored in the base on this cube. I colored in the base on this rectangular prism. I colored in the base on this cylinder. I colored in one of the bases on this triangular prism. All right? So the base here, if I find the area of the base, which is this times this, so side times side, and multiply times the height, which is also the side, because on the cube, all the sides are the same. They have the same exact measurement. So it will be this side times that side, which is side times side, which is, when we've been doing exponents. So that's just side to the third power. So if this was 2, for example, it would be 2. This will be 2, this will be 2, and your answer will be 8, because 2 times 2 times 2 would be 8. And if we were measuring water, for example, it would be 8 milliliters, let's go small, cube. That's how you would write your answer. If this was milliliters that we were measuring of water, for example. So, same concept here. Normally, when you're doing volume, you have 3 numbers. Like here. It's the length of the box times the width of the box times the height of the box. You've seen that before. So the question is, how much water or sand or worms can fit into this box? And to find that answer, you get the length times the width times the height. That's going to give us the volume. Those are our 3 numbers. Another way to look at it is the area of the base times the height. Now the area of this base that's shaded in is length times width. Here's your area, length times width. You get that answer, multiply times the height. That's going to give you your total answer. And your answer will be in some measure. Let's make one up. It could be centimeters. Whatever your answer is, it's going to be to the third power. Because you're going to have centimeters times centimeters times centimeters. That's just one example. Could be miles. Could be any type of measure that you use. Could be a lot of things. And then you have your cylinder at the bottom. Now in a cylinder, the circles represent the top and the bottom, and the height, like on a paper towel roll, tells you how tall it is when you stand it up on the floor. So, but on the cylinder, you need the radius. The radius is how far is it from the center of the circle to the edge. And here's your formula. In this case, volume would be pi, which is 3.14 for you mathematicians out there, times the radius, this number, to the second power, or this number times that number times however tall it is. That's just a review. But right here, here's the problem of the day. Triangular prism. We have a triangular prism here. It is identified by these letters on the edges. We got A, B, C. D is back here, and E is over here. We got F, G here. And so you can see the structure looks like a tent. In the right triangular prism, segment BG, B down to G, is perpendicular to, that means it connects at a 90-degree angle like a doorway, is perpendicular to FC. So this line comes straight down and intersects, not necessarily intersect, but when it hits it, it's a 90-degree angle. That's why you see the red box right there. That means it hits it perfectly at 90 degrees, straight up and down. Here's the problem. Remember what the formula is. We're going to use the volume, and we're going to use the shortcut, equals the area of the base times, I'm going to use the big H for the height. All right, here we go. So I want to find the volume. Here's the problem. The volume of the prism is 900 cubic centimeters. So in other words, when I get my answer, it's going to be in centimeters cubed. That's what it's telling me. I got to put that in the back as my unit. The volume of the prism is 900 cubic centimeters. The height of the prism is 15 centimeters, and the height of the triangular base is 10 centimeters. What is the length of edge FC? In other words, it's asking me what is the length. The question mark is here. What is the length of edge FC? What is the length of edge FC? From here to here, it's asking me, what is that? That's the question. How far is it from those two red dots? All right, let's see what it's telling me now. It's telling me the volume of the prism is 900. Volume, V, equals 900 right off the bat. First sentence, I have part of my answers already. The height of the prism is 15. And then it tells me the height of the rectangular base is 10. Well, what's the triangular base? The height of the triangular base is 10. So what is the triangular base? Well, you find the triangle. You find the triangle. If I know the height, this looks like height to me. From B to G, that's how tall this triangle is, and therefore that's how tall this triangle is. If I was to draw a line, it's the same triangle on either side. How do I know that? Because it's a triangular prism, and a triangular prism has properties. Properties meaning certain things must be true to make it a triangular prism. So if this is a triangle, and it's a triangular prism, then this other triangle must be the same size. So this height is the same thing as this height. That's how tall it is. So it's telling me it's 10. So right now I know this is 10, the line in the middle. And if I stand this thing up on the triangle, like I would stand that cylinder up from the paper towel roll, if I stand that up, this is going to be 15. It told me centimeters. This is also centimeters. That is all the information I need. And all I need now is the area of the base times the height. Well, we know this is a base, and we know the triangular piece, and we know this triangular piece is also a base. I could turn it on its head like that and make it a base. And if it's a triangle at the base, I need the formula for the area of a triangle, because it's asking me for the area of the base. Well, really, what it's asking me for is the area of a triangle, because the triangle is the base. I can substitute base for triangle in this case. So area of the triangle, and the area of a triangle is 1/2 the base times the height. That's a formula that is mathematically proven. This is the formula that you always have for the area of a triangle, times the height of the entire prism. So now all I have to do is substitute in my numbers. So 900 equals 1/2, and I substituted in the formula. This base B is equivalent to FC. The same thing we're finding. FC, the segment, is the same base of this triangle. So that's what I'm looking for. So I'm going to keep B right here. but it tells me that the height, this number is the height of that triangle. The height is 10. And it also tells me that the height of the whole thing, the big height of the whole prism, is 15. Whoa, look at that. Now all I need is B. Now it gets real easy. This is the algebra piece, by the way. So 900 equals, beautiful thing about multiplication, this piece right here, all of it's multiplying. I can move them around and multiply. 1 times 2 times 3 is 6. 3 times 2 times 1 is 6. 2 times 1 times 3 is 6. 2 times 3 times 1 is 6. I can move those numbers all around and still get 6. So I'm going to say 1/2 times 10. Now some people are like, you know, how you used to do in class. What's half of 10? If I ask you what's half of 10, you just say 5. Don't make this a mathematically challenging problem. So 5. Half of 10 is 5. 5 what? I got B's left over. Times 15. I'm still solving. 900 equals, I'm still multiplying. I can take this number and multiply it times the 15 and get 75. 75 what? B's left over. I can turn this equation around. We talked about that before. 75 B's equal 900. That's a one-step multiplication equation. Now I can divide both sides by 75. That's 1. You know, that cancels out. 75 over 75 is 1. 1 what? B. Make that look like a 1. Equals 12. 75 goes into 900 12 times. Or simply 1B. If I see a B, how many B's you see right there? You see 1. So I don't need the 1 there. 12. 12 what? That means this side right here is 12 centimeters. There it is. Peace.